Hi, so we are looking at week 7, day 2 today. And the question number 1, which I'm going to go through with you first, is 2.5 add 4.25. And as always, I'd like you to think about what you already know about these two numbers that you've got here. Can you remember what they're called when you've got a whole number and part of a number? Yeah, they're mixed numbers. So having a look at these straight away, I would look at my 2 and look at my 4 and say, right, I know that 2 add 4 gives me 6. Okay, so I would write down over here, I'm just going to put my 6 because I know that 2 add the 4 equals a 6. I'm just going to rub those off so we can see that we're just focusing on our half and our quarter. Now, half and a quarter, you're introduced to halves and quarters quite early on in first school. But if it's been a little while since you've looked at them, you might think, oh, I can't remember how to add a half and a quarter. So what we can do, we can get our whole. And because quarter is our smallest amount, we can split it into 4 equal parts. So I can say, okay, I know that half of my whole is going to be 2 of these cubes. I know that a quarter of my whole is going to be 1 of these cubes. So I know that half add a quarter is going to give me 3 quarters because I have 3 parts to my whole. So I know that my answer for that question is 6 3/4. Lovely. Okay, let's rub that one out. We'll have a little look at question number 2. So question 2, another fractions question. And I'm going to go through this one. 2/6 add 5/12. Now again, look at the fractions that you've got. Look at those denominators. Look at the numerators. Can you spot a relationship? So the relationship here is between the two denominators, isn't it? Now, 12 is a multiple of 6. So we can add these together. So I am going to start off with my 12ths, and I'm going to get how many 12ths to make my whole. How many cubes do you think I'm going to get to make my whole if I'm working in 12ths? Let's see if you're right. I have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 12, and that is my whole. 12ths. 12 12ths. How many 6ths do you think I need to make a whole? Yeah, I need 6, absolutely. So I'm going to get my counters that represent 6ths. So I've got 1, 2, 3, 4, 5, 6 of those that make my whole. Now remember, if you don't have these, you can use anything or you can draw it out. You can draw it out as well. So to add 2/6 and 5/12, I need to find a common denominator. And I'm going to use 12ths. So I'm going to turn my 6ths into 12ths. So I would draw a little arrow, and I'm looking to see what I do to my denominator of 6 to turn them into 12ths. Well, I can see that for every 6th, I have 2 12ths. So I'm going to multiply my 6 here by 2. That's going to give me 12. Now, because I've multiplied my 6 by 2, I also need to multiply my numerator by 2, because we need to keep the value of the fraction the same. It's just the representation that changes. So I can see I've got 1/6, 2/6, and I can see that I've got 1, 2, 3, 4 1/12 is equal to 2/6. Now, does that fit what I've just showed you to do here? Is 2 times 2 4? Yes, it is. So there's your proof. There's your proof that whatever you multiply your denominator by, you also multiply your numerator by. Okay? So I've got 4/12, and I can add my 5/12 now, and I can do that without using my counters. I can do that without using my rods because I've got a common denominator, which means I can just add my numerators. Denominator does not change because they're still 12ths. I have 9 12ths. Lovely. Okay, next question. I have, an improper fraction. Oh, I've got a mixed number that I am going to turn into an improper fraction. So I have 4. So these are my wholes. 1, 2, 3, 4. And I have 2/8. 4 and 2/8. So if I was going to draw this out, because some of you might think, right, I'm going to draw this out, I would draw a hole. Doesn't matter how big it is. And I would draw another hole. I would draw another hole. And I would draw another hole. And just try and make sure that your holes are the same size. Oh, they're a bit wonky, aren't they? And then split them into 8 equal parts. Now to do that, half it so you've got 2 equal parts. Half those halves so you've got 4 equal parts, so you're in quarters. Then half those again so that you've got 8 equal parts, you're in eighths. And then you can follow those lines down and split the rest of your holes into 8 equal parts. 2, 3, 4, 5. Lovely. And I've still got those 2 extra eighths, so I'll draw my 2/8 on here. And if I'm working in the concrete, I can put my 2/8 down here like this. So it says change it to an improper fraction. Now you can do that by counting out how many eighths you've got. So you could start off with 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, and you could count all the way down. Or, you know, you could get counters and you could put it next to each one and see how many there are. But there's a quicker way to do it. Can anyone think of a quicker way to do it? Yeah, if you know this is a whole and it's in 8 equal parts, well, you know that that's 8/8, isn't it? And then how many eighths is it with this second hole? Well, you're adding another 8 on, aren't you? So it's 16/8. And then you're adding another 8 on here. So we're in our 8 times tables now, aren't we? So we've got 24/8. And then down here we're adding on another 8/8. So we've got 32/8. Don't forget about these that were part of the original fraction, which was 4 and 2/8. You've got to remember to add these two extra eighths on. So add 2/8 is 32/8, and we've got 34/8. And that is your improper fraction. Fab. Okay, last question. 500 less than 3,117. I'm just going to write this one out. 500 less than 3,100 and, oh, it wasn't 17, 3,171. What's it asking us to do? Well, it's saying take 500 away from 3,171, less than, 500 less than. So 3,171, you can either take off the 100 so that you've got 3,071, and then take off 400 from 3,071 to give you 2,671. So you can either do it as a mental method or with some jottings, or you can double check it by using the formal written method by subtracting your ones first. So 1 take away 0, and it helps to say it out loud. I always find it really helpful to say it out loud, and I'll tell you why in a minute. 1 take away 0 is 1. 7 take away 0 is 7. Now 1 take away 5, we can't take away 5 from 1. Now that's where it's really helpful to say it out loud, because sometimes if you don't say it out loud, you see the 1, you see the 5, and people sometimes fall into this trap where they take the 1 away from the 5 and they'll put 4 down here. And then 3 take away something, they'll just put the 3 take away nothing, you'll just put the 3, so you would have had 3,471, which is actually 300 larger than the original number you start with. So in this case, we're going to do an exchange. So we're going to exchange 1,000 for 10 100s. So I've got 11 1,000s take away 11 hundreds take away 5 hundreds, which is going to give me 6 100s. And I've got 2,000s take away nothing is going to give us 2 1,000s. Lovely.